Controlling points with infrared detectors. Will it work? Specifically, will it work on Halton Warren 009? Hi, welcome back to Halton Warren 009. I'm Mark. At the end of my last video I mentioned that this video would be about building the Helix. That is not happening. The reason for that is basically I haven't had the time to do it. The following weekend after the last video we went off to Pembroke for 4 nights, which was nice to get a break. And then last weekend something else happened. It was a lovely day, Saturday. Oh yeah, I got married. So getting married kind of blew any thoughts of model railwaying out the window. So everything's been postponed tonight. It's Tuesday night. Tuesdays nights, the missus, and she is the missus now, goes off for a night out. She either does Women's Institute or she does rock choir, and tonight's rock choir. So she's going to be out for about 2.5 hours, which means I've got the house to myself. I can please myself what I do. And so the project tonight is going to be to see if I can wire up infrared detectors to operate points. Now, Larry Puckett, the DCC guy, has done something almost identical, but he used current sensing detectors on his railway. He's doing a reversing loop, and the point at the end is going to be controlled by, as I say, current detecting sensors, so that the points will automatically change as the train goes around the loop. So that's what we're going to try tonight. Okay, projects like this I would normally do inside. Upstairs we've got a spare room and I've got a desk there. Thing is, it is a desk and I do use it for when I'm working at home, so the computer's set up on there at the moment. There's also a couple of projects for the railway set up there, so there's no room to actually work. Now I've got cleared this baseboard ready to work on anyway, so it's an ideal thing to use. Right, so what have we got? What are we going to use? We have got a DCC Concepts Colbert IP digital points motor. Now with these, the terminal block at the end comes with little clips so you don't have to do any soldering. Now the top 2 terminals on here are DCC in and DCC in. So that's where the power is going to come in to actually control the point motor. The bottom 3 are for the IR devices to put their input in, and their input again is another voltage, and that voltage, once that's detected, that will make the point motor move whichever way it needs to go. So the 3 holes, we've got the middle one which will be the ground, the bottom one will be a voltage lead coming from one of the IR devices, and the 3rd hole will be the voltage lead from the 2nd IR device. Right, that's that bit. What else we got on here? I'm going to use one of these junction connection terminal blocks. Now Charlie Bishop at Chadwick seemed to be the first bloke to highlight these. I remember shortly after he did, they seemed to vanish for a while. Anyway, the bonus with these is that normally you would have to put little loops of wire between each terminal to bridge them, but these ones come and you get either a red one or a black one, undo all your screws, slot it in, do them all up again. These snap as well, so you can either have 2, 3, 4, 5, whatever configuration you want. This is a 12 one. It's too much for what I need for down here, but for the purpose of just putting this test read together, it's fine. We have got a screwdriver, obviously for just tightening things up. At the back here I've got my test track with my NCE power cab. That's going to supply the power to the point motor. I also need 5 volts. The devices, the detection devices, have 3.5 to 5 volts I believe. So what I'm going to use for that is a plug-in transformer adapter. This one's got variable voltages on the back, so you go 3, 4.5, 5, 6, 9 or 12. I've set it for 5, that's the maximum these take, and I just want to make sure they get enough of a kick. And these are regulated as well, so the current should be fine on them, or the voltage should be fine on them. The detectors themselves, we have got 2 LED type items at the top. The clear one is the one that puts out the infrared light source. The darker one, the black one, is the receiver. Down here we've got 3 terminals. I've already wired these up to save a bit of time, but the blue one is my voltage in. As I say, that can be 3 to 5 volts. The orange one is your ground out, and the green one is the voltage lead to the point motor. Now both the green and the blue terminals have got little pluses on them, so you know that's the voltage going through. Now when they're just sitting here, the power comes in through the blue, powers the unit, and goes out on the orange. We'll get to the what the green one does in a minute when I wire them up. Now just above the pins for the wires are 2 micro LEDs. If this one's on in its own, it means there's power to the unit. If both of these are lit up, it means power to the unit and the device has detected something. Then here we've got potentiometer, and the idea of that is so that you can adjust the sensitivity. If it's all the way around one way, these will stay on forever. If you turn it all the way around the other way, they'll obviously go out. So what you need to do is judge and test how far, when you've got something above it, how far you need to turn the potentiometer just so these work at the right sensitivity. Okay, I think that's everything we've got here. I'm going to just zoom you out again, and then we'll get on to wiring this unit up and see if it works. Right, I'm going to start with the point motor. We're going to use the DCC in and the DCC in, which are the 2 terminals on the right hand side. Now I've cut some wires ready. I happen to have some black and red just close by, so I've used that. Obviously being DCC, it doesn't matter what colour wires you use. This power is going to be picked up from the track on my test track. It can be come off there, or it obviously can just come off your bus wires. So that one's in. Get the second one in. I'm using a flat bladed screwdriver because it's a darn sight easier than trying to get your thumb in there to do it. Okay, I'm just going to push that in a little bit more. That's it, because I had some bare wire sticking out the top. Right, the other thing we want to go on here is, as I said, these 3 are the 2 leads to come from the IR detectors, and that's when the voltage comes into those, and that tells the point motor which way to go. And then we have the ground lead coming out the middle. So I'm going to put these in order because it makes life easier. So there's one in. Then I've got a ground which I've kept as orange. No, didn't hold. There you go. And then the other device, again, we want the green, and that comes into the 3rd hole, or the furthest left hole. Okay, so on here, as I said earlier, we've got 5 volts coming on the blue, going in to the device. The ground is the orange, so that's your circuit for powering up the device. The power comes in through the blue. When the device is triggered, that voltage then goes out through the green into the point motor, triggers the point motor, but obviously you need a ground for that as well, so that's your orange wire. And the orange wire, the ground, is shared by both devices. Right, the next bit I'm going to wire in is this block here, and I'm just going to use this for the commons, the grounds. Doesn't matter which order they go in. These are just going on here, and it's slot in, tighten down. And the next one, in fact I might zoom you out a bit, it's going to be, if I can, that's better, I can see a bit more now. It's trying to do this without tying all the ropes up, without tying all the wires up, so that you lose movement on them. And then this is the 3rd one. And that one goes in there. And we can just screw that one down as well. Right, now the 5 volts that's going into the devices, obviously we can put those onto a shared terminal. Now what I'll do is, when I do this for real, if it works, which I'm sure it will, is I will split this block so that the returns at one end and the feeds are at the other end. For now, what I've got is just a normal chocolate block thing. This is already wired up to the positive of the variable volt little transformer thing, plug-in transformer I showed you a moment ago. So if we can get all those in there, are they all going to go in? This is why I need to put them all on the terminal block rather than using this fiddly little thing. That's better. Got them in. Hold them in place, screw them back down again. Make sure they're tight. How often do you put these in and then give the wires a tug and it disappears? While I'm here, I'm just going to, no I'm not, because that doesn't go in there. Right, so I've got the power coming from the plug-in little transformer. I've got my 5 volts coming in, going round into the feed, into this block. The 2 feeds coming out to the detectors. Then the returns going back to this, or the grounds coming back to this. And then the 2 green wires which is feeding the voltage to the motor. So that's all done. Right, the next thing we've got to do is get power to the point motor itself. Now, I don't think I've given me, no I haven't. Lack of planning here. If I swing this round. Okay, what I've got here, if I just move you up a bit so you can see, hopefully you can see, this is my test track. It's not, some of it, there's an isolation point on here. This is all isolated. So I've just got a DC controller there if I want to. I've got some little HOE engines upstairs that are quite cute, so I play with those on the back there. But the front track is my test track. That's connected up to my NCE power cab. So that's feeding onto this track here, the front track, which is my test track. As I said, I've soldered 2 wires onto there and then I've put them into a little block. So what we've got to do now is put one of these into here. Then we will have power going into the point motor. My shakes are a bit more, oh, famous last words. I was going to say my shakes are a bit under control tonight, but they're not. Right, 1, 2. Again, it doesn't matter which way around you get these. All we're doing is picking up the power from the DCC bus wire or the tracks. Right, that's in there. So all that's wired in. The only thing that's not wired in at the moment is the negative or the return for the ground wires going back to the plug-in transformer or power supply. So I'm just going to stick that in there, tighten it down. As I say, I'm going to put spade connectors on these when I do it properly and get everything onto one of these. It's a lot easier than all this fiddling around. Okay, now what we should be doing, and if I just turn you down a bit again, is I'm just about to plug all this in. And what we will hopefully find is that at least one LED on both of these, and 2 might turn up on that one because it might just reflect off the cork bed. The LEDs should light up, and also we might hear the point motor go. So I'm going to plug all this in and see what happens. It's just looked at the floor and realised I haven't got my extension lead plugged in. Give me a moment. Right, extension lead plugged in. This is the cable for the NCE power cab. That's just lit up. Give it a second. Yeah, the red lights come on. Okay, so that the point motor's just decided to move on its own there. Okay, so the green lights have come on. If I just lift that one off, it should go out again. Right, so that one was down. This one was down, and two LEDs came on, which showed that that picked up the surface of the cork and operated the actuator on the point motor. So if I do this one, you saw the two lights come on there, and the actuator's gone on the points again. If I do it on here, there's the two lights are on and the actuator's gone again. Hopefully you can hear that going in the background. So what does that mean? That means it's a success. A success. Wonderful. Now I said it would work because this is so just like Larry Puckett does it. Obviously other people use it as well. It's the first time I've tried it. It's worked first time, which is brilliant. Quite unusual for me. I do struggle getting things to work. Right, I'm just going to clear this. If you always want the train to go over the points the same way, you have one device one side of the points and one device the other side. So the train comes in, goes over here, the points are set to carry straight on, goes over the second sensor, and that changes the points so you can go out again. Okay, now when it goes out, it will go over this device and reset the points back into the line, the original line. Okay, if you want the points, the trains to come in and I go round one way and then the next one to go on the other one, the points are obviously there. Here's your detectors. And the train comes in, goes over the points, sets it over this detector which activates, but the points are already in this direction. The train goes round the loop, comes back out, hits that detector, which changes the points that way so the train can go off. The second train then comes in this way, the points are set this way, so it goes round, hits that changes the points across, and it goes out. And it will just alternate that every time the train goes. Right. These point motors are designed and worked so they operate slowly, which is why we buy them. And it's the purpose, that's what they're there for. It gives you a nice smooth change backwards and forwards. Because it's slow, what you don't want to do is put these devices too close to it. If that's that close and your train goes across it, activates it, and then hits the points while they're still activating, you're going to get a derailment. So these need to be a bit of a distance away. So in my case, the point motor is going to be over here. The detection devices are going to be over the back here. So I have got the length of a train between. So the points are set, it comes round, it goes over the device, and it's got all that distance to go before it hits the points, and they should be set by that time. The other thing you've got to do is keep the speed of your train down. Otherwise, if it's too fast, it's going to get to the points before they've changed properly, and again, it's going to fall apart and derail. Okay, my point motor, as I say, the points are going to be here somewhere. The line, this scenery on this section was set up before I decided to do this. So just move my church a little bit. So this route at the back here was going to go off into the quarries and then just have a run round. So the V-tippers went in, engine uncoupled, went round, reconnected and off again. And then this path here was going to come into a halt station on this board down here. Now the fact that they're going to go into a reversing loop now, I've got to alter this. This little hillock has got to come out so I can get the track lined up with the loop and still keeping it on a 12-inch radius because that's the smallest I want to go. The other thing is, here's the point motor and it should be under the board there. Again, not very good planning. So what I'm going to have to do is dig this out. There is board here ready for it to get mounted under, but I've just got to cut this section out, put the motor in and then realign a small bit of board in there for the track to sit on to come out. Okay, so that was fun. It's something a bit different. The question was, can we control point motors using infrared sensors on Halton Warren 009? The answer is yes. Now, I knew it would be yes, but it's whether I could actually do it. I very rarely get things to work first time, and then I struggle, lose confidence, and it takes me a while to get on top to what I've done wrong. But I get there in the end. Right, now we have got it working. What's the next step? Well, the next step is to get away from a test rig and put it in permanently on the layout. So the work I've got to do, I've got to mount that new baseboard properly, secure it in place. I've got to dig out the hillock. Once the hillock's dug out, I can put in the point motor and wire that in. Once the point motor's in, I can put the track in. Once the track's in, I can then put the sensors in, because I will know exactly where I want them to go. To put the sensors in, I want to change the diodes. At the moment, these are 5mm. I'm working 009. The distance between the rails, therefore, is 9mm. To put 5mm diodes in between them might be a bit tight, so I'm going to go for 3mm diodes. Now, the naive gauge model railway chap, he has changed his to 3mm. He's working in N-gauge. Didn't seem a problem. He literally took them out and wired the new 3mm in on little lengths of cable so that he can be a bit more flexible. What I want to do is mount these circuit boards on a separate panel and then have the diodes at the other end of the track. Now, to do that, I'm not going to hardwire them into the circuit board. I have bought a number of these little right angle pins that are specifically designed for circuit boards. So I'm going to put 4 of them in there. Then I'm going to put my 3mm diodes on long lengths of wire. On the other end of the wire, I have bought a pack of these, and these strips of wire have got a female connector at both ends. So I'm going to chop them off one end, solder that to the length of wire that I'm going to use, and then this end that I'm going to keep the connector on, that can simply plug into this little circuit board, and I'll do that on both sides. Now, the idea of that is, if this circuit board fails, instead of having to unsolder it, all I can do is unplug it, put the new one in and plug it in. These are about £1.50, £2 each, so if they do break, they're not difficult or expensive to change out. Okay, so we've got the track down, we've got these in place, we've got the point motor in place. We need to control it all, so we need the wires to feed back to somewhere where we can manage them. So what I'm going to do is produce and make a little tray that slides under here. On that tray will be the Gauge Master reverse loop polarity switch. So that will be automated, changing the polarity. I'm going to put these sensors on here as well, and the reason for that is, once the sensors are in place, I've got to adjust these to pick up the train going over the top. The last thing I want to do is keep crawling under the baseboard, adjusting it slightly, coming back out, rolling the wagon over it again, seeing if it works. If not, go under, adjust it. If they're on a pull-out board, I can reach them easier, and that goes for the other stuff as well. I'm 6'5", I'm slightly overweight, alright, lied there. I'm 65 years old, I've got a dodgy knee, I've got dodgy toes. So to actually get down on the floor is easy. To get back up again is a nightmare. So I'm going to put everything on a pull-out tray, and that's just going to make life a lot easier for me. So what else is going to go on that tray? Well, obviously it's going to be these 2 circuit boards for these sensors. I'm going to use terminal blocks instead of the chocolate block, because these for me are easier. They're bigger screws. I shake a lot, as you probably noticed, so they're just going to be easier for me. I have actually started wiring some of these up. So I've got the 2 green lines which take the power, the voltage from the sensors to the point motors. I've got the 2 blue wires which takes the 5 volts power feeds to the sensor circuit boards, and I've got my earths or my grounds in there as well. Needs a bit of work still. Not all the cables are on there, but using one of those keeps it tidy and it's easier for me to actually use. The other thing on there will obviously be the gauge master, and that's it. Once all that's wired in, I might put the power source up there of some sort as well. I've got to tidy my power up, but we'll come to that at another stage. So that's it. The board will be down, the baseboard will be down, the track will be down, the points will be in, the sensors will be in, everything will be on the control board so I can pull it in and out. I'm changing out the diodes for 3mm. I'm also changing it to pins so I can replace them if I need to easily. That's basically it. That will be the track in place and on this side of the board, and that, as far as track's concerned, will be finished, which means that I can then concentrate on the other side. Right, so where am I with this last bit on the left hand side? Fiddle yard is in limbo at the moment. I still haven't received the last two 12-inch radius left hand points, and I can't lay my track until I've got those in. Once I've got those, I can lay the track, I can put the point motors in, I can start wiring all that up. The other thing is the helix. That's all in bits. That's ready to be put together, but I need to get outside again and have the good weather to do it. I then will need the track to put on it. That's going to be 20 to 25 lengths. £4 to £5 a length. We're talking about another £125. It's all money. It's all money. Right, so when the helix is done and the fiddle yard is done, I then need the framework to mount it on. So if I'm going down to buy that from Anthony, the track and the points, I might as well pop in and get the timber for doing the framework. Then I can get all that done, and that means that then the track work will be done up to the scenic baseboard level. Once it's there, then I've got to start working on the two scenic baseboards. There's a lot of work to alter those, but I do know what I want to do with those, so that should be fairly straightforward. I've got the points, I've got the track, so that should be all a goer. Happy times. I'm still very focused on what I want to do. It seems to be coming together. I'm enjoying doing it. I like putting these videos together. They're very helpful, as I said before at some time, to actually watch them back and listen to what you're talking and realising what my thought processes are. It's very useful. This is video number 8. I've got 3 subscribers who I am so pleased to have. There's not a lot of content been in this so far, but to actually have 3 people that step forward and want to be subscribers, that's very pleasing, and I would like more. So if you feel like you like these videos and you feel like I'm doing an okay job with doing them, maybe you're subscribed too. I will leave it there. I'm waffling on. Happy modelling. Hopefully you'll tune in another time. Bye for now.